Alright, how are you doing for today? And how is the practice so far, the tutorial so far? Hope you are doing good, right? Okay, alright, that's nice. Okay, let's see what we can do today. We want to talk about some properties of real numbers. Some properties of real numbers. And then these properties we are going to talk about, let's just pick 10 and talk about, okay? Please pay attention to this. At any time, at anywhere, you may be asked of this question. I'm not just saying maybe in exam or test, but please pay attention and then grab it, okay? It's very simple. What are the properties, some of the properties of real numbers? Number one is this. All real numbers can be represented on the real line. All real numbers can be represented on the real line. That is to say, in a number line, you understand what we mean by number line? Look at it. You see something like this. This is called number line or real line. You say that every real numbers or all real numbers can be found in this number line. Any number called real number, you can trace it in this number line. That is what number one property is talking about. Number two, all real numbers are closed under the four basic operations except division by 0. All real numbers are closed under the four basic operations except division by 0. Now what is this talking about? They say when you pick some real numbers and perform the four basic operations. For the four basic operations include addition, subtraction, multiplication, and division. So if you pick some real numbers and perform these basic operations, your result can also be found on the real line. You get it? Yes. Your result is also a real number. Your result can also be found on the number line. That is what it's talking about, except division by 0. You get it? Okay, for instance, pick any number. Or let's just say 1 divided by 0. You say in calculator it will tell you math error. So, it's not possible. You get it? Alright, it's undefined. It's what? Undefined. So that is it. Any number divided by 0 is undefined. You get it? So number two property say all real numbers are closed under the four basic operations except division by 0. So when you pick real numbers and perform the four basic operations, your result is also real. And then your result can be found on number line except division by 0. Good. Let's go. Number 3. All real numbers are commutative under the operation of addition and multiplication. All real numbers are commutative under the operation of addition and multiplication. Now, what is it talking about? Let me just use example and explain it. When we have something like 2 plus 5, it will give you what? 7. Commutative is talking about if you exchange them. Okay, something like 5 now plus 2. it will give you what? 7, the same 7. So 2 plus 5 is equal to 7, and then 5 plus 2 is equal to 7. That is for addition. And then for multiplication, let's just put these two numbers, 4 and then 3. Okay, now we will have 4 times 3, or 4 multiplied by 3. It will give you what? 12. And then 3 times 4, it will still give you what? 12. This is commutative. It is only under operation of addition and multiplication. If you want to doubt it, now let's pick the same number. Let's pick 8 divided by 4. 8 divided by 4. What will it give you? It will give you 2, right? Good. Now, exchange it. 4 divided by 8. What will it give you? It will give you 0.5. Do you see it? It's not the same. But when you say 2 plus 5, 7. 5 plus 2, 7. That is addition. Then when you say 4 times 3, 12. 3 times 4, 12. You get it? But under subtraction, it's not like that. Okay, let's just use subtraction. You can say 5 minus 3 is equal to 2. Okay? Now, okay, let's say 3 minus 5. What will it give you? Minus 2. It's not commutative. Okay? It's not the same. So, number 3 properties of real number says all real numbers are commutative under the operation of addition and multiplication. Okay? And I've just explained commutative. Okay? Alright, now let's go. Number 4. All real numbers are associative under the operation of addition and multiplication. All real numbers are associative under the operation of addition and multiplication. Okay, let me just use an example also to explain associative. Okay, now let's see something like 2 plus 7 in bracket plus 4. Okay, it will give you 12. Sorry, it will give you 13. That is 2 plus 7 is 9. Okay, then 9 plus 4, it will give you 13. Is that true? Yes. And also when you say 2 plus, you open bracket, 7 plus 4, it will still give you what? 13. So you'll discover that in the first one, 2 plus 7 is in bracket. And then in the second one now, 7 plus 4 is in bracket. Okay? Now that is associative under addition. Now let's go to multiplication. We have 3 times 4 in bracket times 6. 3 times 4 in bracket times 6. It will give you 3 times 4, that is 12. Then 12 times 6, that is 72. Okay? Good. Alright, let's see, take the bracket to the other side. Then we'll now have 3 times 4 times 6. That is 4 times 6 in bracket. It will give you what? Now, okay, let's perform the operation in bracket. So we'll have 4 times 6. Okay? 4 times 6, it will give you 24. Now, 24 times 3, it will give you 72. Okay? That is the associative law under addition and multiplication. Do you get it? Okay, let me show you that this associative law is not applicable on subtraction. Let me show you this example. When we have 5 minus 4 in bracket minus 6, if you calculate this, it will give you minus 5. Do you see it? Okay, perform the operation in bracket. 5 minus 4, it will give you 1. Abi? Then 1 minus 6, what will it give you? It will give you minus 5. Is that true? Good. Now let's change the bracket. If you change the bracket, you have 5 minus, you open bracket, 4 minus 6. Okay? 4 minus 6, right? Now let's perform the operation in bracket. The operation in bracket say 4 minus 6. It will give you what? Minus 2. See in bracket. Now say 5 minus minus 2. Minus times minus will give you what? Plus. So we have 5 plus 2 is equal to 7. It is not associative under subtraction. More also, it is not associative under division. So all real numbers are associative under the operation of addition and multiplication. Is that clear? Yes. Okay, let's go. Number 5. Real numbers obey the cancellation law. Real numbers obey the cancellation law. Let me show you an example. If you say something like A, if you say that A plus B is equal to Q, and then A plus C is equal to Q, that means that B is equal to C. Let me explain. If you say that when you pick a number and add to A, and then let's say that that number is B that you picked, and then if you add this B, if you add B to A, that your result will be what? Q. Okay. Now we also pick another number and we call it C, and then we also add it to this A, and it gives us the same Q. That is to say that B is the same as C. You get it? So A, we cancel each other, so we have B is equal to C. Alright? Now again, under multiplication, if you say that A multiplied by B is equal to R, and then A multiplied by C is equal to R, that is to say, there is a number, and then let's call this number B, that when you multiply it to A, it will give you R. And then there's also another number, C. Let's call this number, there's another number, C, okay? Now, when you multiply this number by A, it will still give you R. So that is to say that B is the same as R. That is, B is equal to C. Sorry. That means that B is equal to C. Okay? You get what I'm saying? That means that B is equal to C. Now we say for all A, B, C are real. Or we say for all A, B, C exist in real numbers. You get it? That is it. Okay, let's continue. Number 6. It says, there exists 0, and this 0 exists in a real number. That is, such that A plus 0 is equal to 0 plus A is equal to A. Now look at this. They say, in real number, there exists a number, and this number is 0, such that when you add it to any other number, it will remain the same. You get it? There exists a number in real line, 0, that when you add this number to any other number in real number, it is the same. And this number is 0. Then we say for all A exist in R, and then R is a real number. Okay, now we call this law existence of additive identity. We call this law what? Existence of additive identity. Okay, now we say that, let me explain it again. In real number, there is a number that when you add it to any other number, it doesn't change. when you add it to any other number, it doesn't change. It remains the same. And that number is what? 0. So we say that this is called existence of additive identity. And the additive identity is what? 0. Is what? 0. Additive identity is 0. Okay? Now let's go. When you add 0 to any number, it will remain the same. Okay? Now let's go. Number 7. We say there exists 1 exists in R such that A times 1 is equal to 1 times A is equal to A. For all A exists in R and R is real number. Let me explain this. We say that in real number, there exists a number that when you multiply any real number with this number, it doesn't change. There exists a number that when this number multiply any other number, be it what, it cannot change. It remains the same. And this number is 1. So we call this existence of multiplicative identity. We call this existence of multiplicative identity. And the multiplicative identity is 1. Multiplicative identity is 1. Okay? Good. When one multiply any number, it is the same. Even your name multiplied by 1 remains your name. Okay? Your phone number multiplied by 1 remains your phone number. Anything at all multiplied by 1 is the same. Okay? Now let's go. Even 0 multiplied by 1 is what? 0. That is it. Okay. Now let's go. Number 8. We say for all A exists in R, and then the A is not equal to 0. We say there exists A raised to power minus 1 exists in real number such that A times A raised to power minus 1 is equal to 1. Wow. I read the expression once again. For all A exists in R, which is real number, and then A is not equal to 0, there exists A raised to power minus 1 exists in R, which is real number, such that A times A raised to power minus 1 is equal to 1. Let me explain this. We say that in real number, there exists a number that when this number multiplied is inverse is equal to 1. Hello? There is a number that when it multiplies is inverse, it will be what? 1. And you discover that all numbers in real numbers, they have their inverse except 0. All number has their inverse except 0. If you want to take the inverse of any number, just say 1 all over that number. Hello? You want to take the inverse of any number, say 1 all over that number. Any number it is. Now, when you, okay, for instance, you take any number, let's just say 5. Now, 5 multiplied by its inverse, and I say the inverse of a number is 1 all over that number. Okay, that means it will be 1 all over 5. Okay, now 5 times 1 all over 5 will give you 5 all over 5, which is 1. So, in a real number system, when a number multiplies its inverse, it will be 1. So, in a real number, you can use 2 ways to represent inverse. You can use that number raised to power minus 1 or 1 all over that number. Do you understand? 1 all over that number, or that number raised to power minus 1 is inverse of a particular number. Alright? Good. So we call this existence of multiplicative inverse. We call this existence of multiplicative inverse. Alright, let's go. Number 9. Number 9. For all A exists in R, which is real number, and then A is not 0, there exists minus A in R such that A plus open bracket minus A is equal to open bracket minus A plus A is equal to 0. Hello. Now let's go again. We said that this one is trying to tell us that in real number there is a directed numbers that when you add it to its opposite, it will give you 0. It will give you 0. That is inverse, okay? So, and the inverse of a number, just like minus 2, 2 and minus 2, that is, they are opposite. Okay? So we have a number that when you add it to another number, it will give you 0. Hello. That is inverse. When you add it to another number, it will give you 0, and that number is not 0. Okay? That is additive inverse. That is additive inverse. Number 10. We have what we call multiplication is distributive over addition. Number 10, we say that multiplication is distributive over addition. Let me show you what I'm trying to say here. When you have A times open bracket B plus C, then the distributive is saying that A, you have A times B in bracket plus A times C in bracket. So these two expressions is equal. Okay, is the same. That is what we call distribution. So it is only distributive over addition, not in any other one. No. So multiplication is distributive over addition. So we say 1. For instance, we have A times B plus C. B plus C in bracket is equal to, when you say A multiplied by B in bracket plus A multiplied by C in bracket. Is that clear? You can pick 3 number and then try it. You discover that it's the same. Okay? Alright. Thank you very much. Please and please watch this tutorial over and over again. You get it? So that you can master it and then move ahead. Alright. See you next time. Thank you.